Hello, Adam.
Yo, yo, dude, how's it going?
Oh, good. Thank you, brother. Good. Thanks for doing this. I
No
appreciate it.
worries.
Um, yeah, yeah. How's it going at Soil Ecology Lab? And
Yeah, all good, all good. Yeah, we just got some DNA stuff back from a study we did in Israel of wild wheat. So
okay.
looking at the biome of the root zone of wild emmer wheat. So just quickly glancing over that, and looks pretty interesting.
Wow. And I saw that you chatted to a rebel farmer. Did you chat to the wild farm people as well recently? Was that?
Exactly. Yeah, yeah, we did. Andy.
Yeah, yeah. Brilliant, brilliant connection there. Um, I was listening to Jeff Lowenfall's new podcast just the other day. It's really good. It's amazing how many people Elaine Ingham has influenced and have gone on to like do
Yeah, for sure. Yeah, yeah.
projects. And
Jeff's like one of the longest. I think he's the longest running journalist in America or something, right?
yeah,
He has like a super old, um, uh, some kind of article he writes.
he's a judge, isn't he? He's in like the jurisdiction. He used to be a judge or a magistrate or something like that.
Yeah, yeah,
And then he was just
in
like
Alaska, right?
met Elaine Ingham and got into compost and just realized that just spent the rest of his life writing books about soil and all of explaining it all in simpler terms.
Yeah,
So
yeah, yeah. They were kind of my intro books as well,
yeah, a
along
team
with kind of No
microbe
Dig.
was a yeah, definitely a gateway book for a lot of people, wasn't it? I think.
Absolutely, yeah. So I
Yeah.
still point people to that book when they're getting started because it's he does a little deep dive into a few things and then keeps it kind of surface level, but yeah, really good intro book.
Yeah, definitely. I remember reading Teeming with Nutrients and not getting anywhere near the same amount from it because I didn't understand like
Yeah,
everything else, like the fungi, as clearly. But
we can always do a, session on that if you want. I've been having lots of fun with that kind of stuff, like shaping, soilless media, different chemistry kind of parameters that you can use for different things.
wow, yeah, I mean, that whole field, like I'm just getting into we're kind of all just getting into like the soil compost testing and measurement and
For
evaluate
real.
that. And it's like, and then you just do the plant sap testing and I mean, yeah, bricks testing, and it's all got to be integrated to get a picture of what's going on. So
Yeah.
little, we'll get make baby steps. So I prepared some sort of slides on some of the test results we've had back and others have had back, and I love your feedback. So there's been some super interesting chat going um, on the forum, and yeah, I'll just quickly go through this if that's cool, and
Yeah, yeah.
then we can sort of feed in. So just to outline the process that a lot of us are doing now, it is the kind of hot compost process, but made more viable in cities with the compost tumblers, the ride
Hmm.
or the Jura forms, and then yeah, people are finding that's producing very good compost quite quickly, but the fungal biomass is not coming up. I'll show you some slides on that later. But the process really is we're feeding it roughly in total 1-to-1 woody stuff to food scraps, rich nitrogen stuff, and then aging it in various ways. So this is the complete compost that I had back recently. So
Hmm.
a couple of years after doing it all and maturing it all and feeding it mushrooms and everything inspired by you guys, seeing you guys bring like different fungi from like spent fungi and put them in your compost heaps, like
Yeah, yeah. And last year I collected loads of grassland fungi and blended them, put them in the compost piles. And this year we did a DNA report on that pile, and it has this big, DNA signal from Clitopolis, which are this grassland fungi that I might have picked up. So I think I might have actually been successful with that. So
oh wicked.
I still think that's a good technique. If the mushroom is like, if it can, if the type of fungi can live in a woodland in a grassland environment and also decay wood and stuff in a
Okay,
compost
so
pile.
yeah, because obviously then the question is like you can't really expect mycorrhizal fungi to really stay in your compost, can you? That's just
Not
not how
really,
it
no,
works. You
not
grow
without a
them
plant.
in, yeah, exactly. They're grown by plants. So it's mainly am I right in saying it's mainly the saprophytic fungi that we're sort of,
Yeah, for the most part, yeah,
but still
that's it.
diversity is good and they'll break down, they'll have the keys to the different lignins and different woody materials
For
and
sure. Yeah. There will always be some mycorrhizal, I think, like fungi in a compost pile in spore form, but there's not enough to ever guarantee that, you're going to make a connection with every plant you apply a compost extract to. I
yeah.
don't think it would ever work like that unless you devised some kind of special,
This
compost
is
pile
it.
to do that.
Like that's the thing, isn't it? Is that like yeah, sometimes the fungi will just be in spore form and not. Um,
Yeah, and that's what the DNA is picking up on a lot of that as well, on a lot of just what's in spore form, not what's
so
active. So it's important to get different angles, to come from different. I say to people, it's best to get as many angles as you can possibly get on something and
okay,
track it over time.
interesting. So I'll just quickly outline what this compost is. So this is compost that's like very mature, but after sort of about 8 months, I took a sieve to it. I got this sieve and I sifted it all out. And then I had a test result back after that, and the fungi was obliterated. Like it was way lower than this. It was like
Yeah,
back to 0.00 something. And so I was like, right, sieving it has destroyed like 90% of the fungi. Bad idea. But then I got that lovely sieved compost, stored it for another 6 months, and it's come back up and it's complete again.
yeah.
So
Okay. So yeah, there's some cool points and some, things I can pick up on very quickly.
yeah,
We've run a few tests with blending compost or sieving it, rotary sieves, removing the large particles. We find that it definitely not just the agitation of the process, but also the removal of those large components that aren't yet compost. It really impacts the development of biology in the compost piles. But on top of that, you can't ever really trust one microscopy assay against another, right? We
yeah,
have to do something like three microscopy assays on a substrate or compost to know the variability as well as just the numbers on a single sheet, the variability in that compost. Because we could sieve it, we could take a sample and we could pull a sample that's just at the lower end of the fungal um, kind of biomass readings you'll get out of this particular compost. And
yeah.
we could think we did some damage to it when really it was just within the variability of that substrate. So we have to be careful with trying to,
Jump to these
draw
conclusions. Yeah.
exactly jump to conclusions and draw meaning from something that's not really there. We have to really have the numbers in the data behind
Yeah,
it
I
to give
know.
it
You have
the
to plot
statistical
it over a
validity.
number of different tests and yeah, see the correlate of the average. Yeah, sure thing, sure
But
thing.
we've definitely seen disturbance in compost piles pisses off fungi.
Yeah, 100%. I mean, and it makes sense, doesn't it? Because I mean, that's what's happening in industrial farming. It's sort of shredding and oxidizing the fungi, and it makes sense that if you smashed it through a sieve and it depends on the design of the sieve, I guess, and all these things. It could be a gentle one, and or it could be a violent one, and I guess all of that has a makes a difference as well.
Exactly. Yeah.
So yeah. So anyway, just so this complete compost, right? I did some math here and I put this in a slide and delivered a presentation. I realized that this is totally inaccurate. So I won't this slide again, but I just what I did was I was excited by these numbers and I took the bacterial biomass, that many micrograms per gram. I went on the microgram to gram converter, got the number, and then multiplied it by 9,000 grams, which is how many grams of compost I'm selling.
Is in a bucket, right?
Right, and it came back as these crazy numbers. It's like um, I worked out that 2000 there was I worked out there was 2,204 grams of beneficial fungi in my bucket, making it 24% fungi. But that's just not the case. I think I got the decimal places at least. I,
Right.
definitely somewhat wrong. It's probably more like
I don't think anyone's going to figure that out at the moment. But yeah,
What's the highest compost you've ever had at the moment? Like,
for fungi.
yeah, what have you managed to achieve with your Elaine
So the
compost?
best, I mean, if yeah, if you know, compost is different depending on the biome, right? So we don't really look at anything as being the best. But if we're talking about fungal biomass, um, I think we're looking at about 1,500, 1,600, um, something like that. Maybe,
Okay,
yeah. I don't know if we have a 2,000 yet.
right, right, fair play.
Don't
And
think.
is that does that make it one? Have you done like one to one in compost? Have you done that one to
What do
one
you mean by one?
bacterial to fungal to F to B ratio?
Yeah, 1-to-1 is our standard. That's what we're trying to achieve, and we can achieve that pretty much in every single pile now. Um,
Amazing.
yeah, and it's remember it's like 1-to-1 above a minimum parameter of 135 micrograms per gram
Yeah,
of
yeah.
fungi and bacteria if we go from the sulfur Weber's kind of perspective, and that's kind of what the business is based around. Yeah, so we find most of our piles now we have a huge amount of 1-to-1. Yeah,
And
and we're
so,
ready to
why
scale
are
up
you
now.
getting that in your piles? I haven't got the slide, but people have seen the bays that you do on your website, and I think a lot of people have seen the how to do the Elaine method. But
Yeah.
why does that achieve higher fungal, and how quickly does that take, and why does it achieve higher fungal biomass quicker than what we're doing with tumbling it all first? Is can you give us an
Yeah,
idea?
so I mean, we've made 51 piles and 50% of them have been Johnson Sue's, right? In the time I've been at the lab.
Yeah,
Or I've been involved with 51. Six of them were made off-site, um, and then one of them was made on my driveway. But
yeah,
apart from that, you know, we've done half Johnson Sue's, half thermophilic compost, and for different processes, you know, we worked with a tree nursery. They wanted inoculum. We set up Johnson Sue's in the woods, and they got the highest fungal biomass of any of the compost we've seen, and the widest F to B ratios. It was
right.
something in the 20s, so like
Interesting.
23-1.
So that's super interesting that you said that. So this is the Johnson Sue report that I've had back, which was just a really homemade one with reclaimed materials. But look, this is 6 months in a Johnson Sue, and although
Yeah,
the to B ratio isn't up, the nematodes are through the roof. It's the first time we'd had predatory nematodes,
wow, yeah,
2,000 bacterial feeders per gram. This was this was different because I used it to mop up all the leaves in the garden as well, and I layered 4-week-old Jura compost with like an equal layer of leaves swept up with an equal layer of Jura compost, equal layer of leaves, and I just lasagna up a whole Johnson Sue, left it for 6 months, and this was the results from that. Um,
yeah, it looks really good. Yeah,
Lots of
masses.
life, just like obviously not enough time for the fungi to really go up because it's only 6 months, right?
Yeah, yeah, and the fastest we've seen real good numbers is like 10 months in a Johnson Sue. It might have happened before then, but we didn't see it. You know, we just saw it after
Right.
10 months. We've got good numbers with the thermophilic process after 4 months. So
Really?
sometimes something can happen, yeah, that makes it faster. Um,
And
yeah,
is it any elucidations that you shared in your first chat with us that adding like calcium sources was
yeah. So we've tried, you know, my Johnson Sue was a bit of an outlier amongst all the Johnson Sues we made in the fact that it had like at about 12 to 14 months, it went over 1,000 micrograms of fungi, and that's like the first time we'd really seen that. You know, where you're testing a pile and you keep pulling samples from it, and you keep seeing 1,000 micrograms of fungi. We hadn't really seen that in a pile before that, and in that pile, I put in some different stuff, right? So like stuff you'd maybe use to as additives for soilless media, or you know, just using farming in general, like seaweed, like Ascophyllum nodosum kelp,
yes,
just as a powder, gypsum, calcium sulfate, and oyster shell, just as a kind of um, a source of calcium to balance to to balance the amount of potassium that gets dumped in the early stages of the pile.
right,
And the idea is maybe it because when fungi are in environments, they stop calcium moving through the system so fast. So you generally in environments where fungi are, there's higher calcium. Maybe by raising up the calcium in the initial stages, you could success towards a fungal environment more.
Yeah.
Sulfur is usually a limiting factor in compost piles as well. Um,
Interesting. How do you get sources of sulfur?
well, that is a part of the gypsum, right? The calcium sulfate.
Ah, yes,
So
yeah.
just a little bit of that, it helps make amino acids. If it's a limiting factor, then you get
And
less
when you
amino
say a
acid
little bit,
creation.
say we've like got our super nitrogen rich fungal, bioreacted compost tumbler stuff from a Bryden or drawer. How much?
Yeah,
Like that's about we're dealing
I
with like
would I would
two, three
take
wheelbarrows.
a few different like dry granular inputs that promote diversity. So think like in biodynamics, people put manure in a horn, right? The horn preparation.
Yeah.
There's nothing stopping you reversing that and putting horn in the compost pile. It's just a source of keratin, right? And the DNA work on the horn prep in biodynamics has shown that it feeds keratin decomposers. And if you're a farm and you're putting out manure, if you're a garden and you're using manure as an input, you want keratin decomposers around because it's going to speed up the access to the nutrition held within the keratin in the manure. So, by adding keratin, you're kind of selecting for organisms to be cultured in the pile, and then you can use those organisms to break down organic inputs in the garden.
Mm.
So you're kind of training your compost on the foods that you're going to feed your organic garden, and then you're
Wow.
firing the compost extract at that garden to kind of bring all these organic foods to life, like poof and horn meal, bone meal, things like this.
Wow, you're training. So yeah, what you do is because a lot of these community compost systems are being installed in like community gardens. So like
Yeah,
super high level, um, like urban regenerative food production would be culturing these biological getting these biological compost systems and then training them to eat the supply of organic matter that garden had for like mulches and things like that and
exactly. Yeah, yeah,
so
yeah.
the,
Like a market garden must get really good at this because the crop residues are used to make the compost, and then that compost is used to deal with the crop residues. So there comes like this compounding factor. If you make compost with loads of coffee in it, it's probably going to have organisms in it that are really good at dealing with coffee. So then if you can get coffee, use coffee as a nitrogen input for your garden, and the compost extracts are going to work away at that coffee much faster.
oh, wow.
This was my thinking anyway when I made this original Johnson Sue on my driveway, and it got really good numbers. I was trying to train the microbes to eat the kind of organic inputs that I was using, and then SAF Woodland Management, they copied that, and then they got good results. But they were also in a really really good environment, so
Mm.
they're in like the Chilterns in the woods, and they had like visibly lots of biodiversity in the insects and stuff that were in the compost because of the location.
Right, okay, that's super interesting. I had this meant to be an image here. Oh, look, that's a red protozoa. Have you had them before, the purple protozoans?
Yeah, yeah, we got some. They did generally happen in the older composts that get a bit more
Okay.
fungal.
Yeah, yeah.
Um,
So that I'd had that one. This was in a 12-month matured bay. Same process,
yeah,
but
you start to see the Arcella more around that time as well. When
right.
it gets a bit more
Okay.
fungal, gets a bit more fulvic, start seeing these larger protists with tests.
Okay. Nice. I can't believe it. I have like I swear I had over 1 trillion of them in one compost bucket. Um, does that sound possible?
Yeah, yeah, I think so. I
Because
mean,
I
we
mean,
got
Elaine Ingham
good
I've
numbers.
said she's found
Brilliant, yeah.
compost with 10 million protozoa. I swear she said 10 million a gram. I was
Yeah,
like,
there's
oh,
actually this guy called Ben from Indoor Organics. Have you ever heard of Ben?
yes, heard of Ben.
Ben, he has this shop called Indoor Organics, and they make like soilless
Yeah,
media where they like put all these inputs into it, like what I was saying, like kelp, gypsum,
yeah.
bone meal, and you heat it up, but so it's kind of like a Bokashi pile. it doesn't really get thermophilic. Um, but yeah, you use kind of like mesophilic processes to prepare soilless media with organic inputs. And one of his piles had like a million protozoa per gram.
Oh
So
yeah, I mean,
a bucket could have, yeah, you know,
no,
a
no,
huge.
totally. The girls here, look, these girls, this is their first report. I'd love to give them some feedback on this, but look, they've got 1.4, they've got 1.5 million protozoa per gram.
Yeah, wicked. Yeah.
So it's incredibly good. And this is super similar to our first report, which was yeah, based on the same similar process like that they've been doing. And yeah,
It looks like quite young compost. So
but
this
yeah,
is the
this is 6 to 8 months, this one, 6 months, I think.
mm.
So not you
So
like you say, not that old. Love to give them an explanation of I mean, I basically said you're just gonna have to wait a bit to get your fungi up and it will come. Um,
yeah,
but
that's it.
yeah,
Time is the best ingredient, you know, it really is. There are maybe some priming factors for fungal development. One I talked about the calcium, right? We mentioned that, and then the nitrogen being in the predominant form of ammonium, that
right.
could be another priming factor. If the
So
nitrogen is the predominant form of nitrate, it's
yes,
probably more priming for the bacterial populations and their high trophic raisers. So when we apply the goop to like green waste composts that are they might have more nitrate than ammonium, and they they might be quite bacterial.
yeah,
We see the nematodes and the protozoa take off first, but when you apply it to more fungal media that aren't where the nitrogen is the predominant form of ammonium, and they're a bit more wider C to N ratios, so more carbon rich, we see the fungi take off faster. So the same inoculant being applied at two different materials, two different groups take over faster. So
oh wow, that's really interesting. So are you saying, if I got this wrong, that you're if they were using, so we're using roughly 50% fungal foods to bacterial foods, or favorite fungal foods to favorite bacterial foods in this system.
mhm.
So are you saying if they weren't using so much nitrogen like
That's
input,
it. Yeah,
so
yeah. So as the C to N ratio gets wider, you
yeah.
generally reach more. You start to select for more equilibrium
So
forming
really, then they could
microbes.
just. So really, that's possibly why I'm trying to make some sense, because I definitely started adding. Yeah, two big questions here. So, okay, first of all, can we make fungal compost quicker just by, like you say, increasing the ratio of fungal foods? So, say
Yeah.
we start adding 80% fungal foods and only to 20% of our Bokashi collected food waste.
Hmm.
Would that would just, the fungi would take off and we'd get higher biomass ratios quicker. Is that right?
Yeah, I think so. I think micronized particles as well. Like these machines that
Shredded,
are,
you mean?
yeah, like shredded, or there's like these machines now that like dry, dehydrate, and shred your food into a powder. Those
I
things
mean, that's what
might,
Martin was looking at. Martin, our Bokashi supplier, Agriton, Martin, he's basically saying that they're invested in, they've just invested in a dryer, so a Bokashi pelletizer basically.
yeah, that's
Um,
pretty powerful because then that allows you to create tiny micronized fractions of fungal foods, right?
mm,
So then, what we've noticed as well is that fungi seem to like to grow on the edge, right? They like edge. They like access to water, but they like oxygen generally, especially these kind of early decomposers. They they want access to the water, but they need access to the edge. So if you have a dry powder and you send it into a wet compost pile, you suddenly create lots of edge, right? Because there's lots of little dry particles around wet compost, and that's kind of like really good food for these fungi. They're gonna like that. They like that kind of semi-dry state because drybacks
oh yeah, so
happen.
it's what they like teach on the soft food web course. They like 50% moisture. That's ideal for them, right? Like just
Exactly, yeah. But you seem to select for them with drybacks. So what I like to do is kind of very little management for the compost piles. if we
Mm,
can do that. So unless it's like 40 degrees summer, then it's like, it's time to water the piles and save all the microbes. But if it's
sure.
not like that, we kind of let the piles dry back a little bit and then
Yeah.
wet out again. And that seems to select for fungi because if
Definitely, the wetter conditions, the more like the worms love it, the wet, don't they? But they
yeah, and but
definitely
it
know.
goes when it goes anaerobic and it goes fermentative, then it starts to preserve the compost and it
Okay,
delays the onset of the fungal development, right?
that's super interesting. So yeah, we definitely need this state where you have the tumbled compost, and that can, depending on how dry your carbon is and how wet your food waste is, that can end up really wet or really dry. You've got to monitor that stage of the of the process in the tumbler.
No
Um,
doubt.
and then it's like, I think after that, the best thing to do is to get it to the worms where it can be open and hope and keep it wet. And then I've kind of been advocating for a fungal phase, which is in a more sealed thing that also allows evaporation. So like these wooden boxes which keep the rain off but allow evaporation.
Yeah.
So um yeah,
Yeah,
that's
we've considered potato boxes and stuff like that. Um, it's
mm,
yeah.
this is all
Gore-Tex might be cool if you go super high tech, but
Gore-Tex.
yeah, like the stuff that like breathes but keeps
Wow.
moisture in.
Gore-Tex lined
Gore-Tex might be really cool.
monsoons or something, or
What's that?
Gore-Tex lined, like, yeah, compost chambers. That would be next
Yeah.
level, wouldn't it? Wow.
Yeah, that
Um,
might be the future stuff, but
I mean, when we
just
when
in a
we
Johnson Sue in a nice environment. I think the environment does a lot. I think the environment does a hell of a lot.
I mean, definitely the environment brings in, like, the birds. They bring in
That's
microorganisms,
it.
don't they?
That's it.
It's got to be
No,
connected to the ecosystem. That's one of the biggest drives of this whole thing. It's like,
that's it.
stop this
Yeah, as soon as
copper.
we put a bird feeder in our compost piles, we saw fungal feeders turn up.
Oh wow, this is it.
So like
Even
and,
like
and
slugs
predators
and
and stuff and
snails are
interesting
pollinating
stuff.
different creatures, aren't they? Everything's carrying biology, seeding different
Yeah, I
biology.
mean, you can go and do natural farming, microbe collections in the woods, or you can just stick a bird feeder in the compost pile, like.
Amazing. Bird feeders in the compost stations. Okay, it's the next. That is an actionable step we can all take. That's great.
Yeah, for sure.
All right. Big question now is, so this batch and all the batches, I've noticed. Have I got a picture of what we've been doing? Yeah, this Bokashi stuff. So at about that, so yeah, this time last year, I started giving everyone these pots of Bokashi and
Mhm.
and telling them to put it in their bucket. And I haven't been doing the tests regularly enough to really know, but the ones I did at about 6 months interval, they really showed an increase after the compost with Bokashi. And I really noticed it within the drawers. Like, instead of just the normal steamy process, you get these amazing growths climbing around the drawer, like different.
Does it get yeasty and kind of like
Yeah, it
um
smelled like more like, yeah, it smelled like the Bokashi can smell sometimes, and the patterns were like Korean natural farming molds and growths and stuff, rather than,
interesting? Yeah.
yeah, it was interesting. And anyway, I noticed better F to B ratios 6 to 8
Yeah.
12 months down the line because of which I have attributed to the Bokashi. So can you
So
explain?
how many months down the line is this?
So, and I know I've never tested anything less than 6 months down the line. I've just looked at it, and it's just been like loads of nematodes and
Yeah,
ticks.
I mean it looks drier, with the bacterial biomass is definitely lower. So that's yeah, for a 6 month old pile, that's pretty low. You'd expect it to be in the thousands still. So there's some things maybe happening there. You can manipulate these things in a kind of cheap way. So you can just dry back the compost and then you manipulate the F to B ratio. But it's not exactly what if you're trying to shape a biome and ecology, it's probably not the best way to do it. But you know what I mean? Like you just dry a compost back, and as you dry it back, the water decreases. As the water decreases, the bacteria will decrease. So then you manipulate the F to B ratio like that.
Okay. Yeah, because it's interesting. You can dry compost out quite easily. Like I did it just the other day, and I weighed it before and after. I raked all the compost out in the sun. I just put a big tarp out, spread a whole bay of compost over it, and I left it for a whole 6 hours in the sun. And I weighed a bucket before and after, and it had decreased by like 600 grams of evaporation in April. On a
Yeah,
so
yeah.
um yeah, it's quite quick to dry your compost.
Yeah, it's like this living thing. It's like breathing and it's alive. It's
Yeah. Okay, so what was that thing that you mentioned? Because I'm super interested about how is Bokashi is affecting the compost. So you mentioned about you've noticed that there was some impacts where Bokashi at a certain time has been popping protozoa like nematode and protozoa populations. Like
not Bokashi, no.
no, okay.
Just when you go from IMO 1 to IMO 2,
Right.
when I start, because I came from natural farming into soil food web, so when I got the microscope, I was keen to start looking into these processes that I was doing with the natural farming stuff. And I just found that you can collect nematodes and protozoa in rice. You can actually collect them, but you pop them with the sugar as soon as you add it. So as long as people know they're doing that, then they're doing that. I'm not saying it's a bad tool or anything. I'm just saying that you don't get those higher trophic grazers like you do um, from a young compost, right? Where you see like the girls had, they had high levels of amoeba in a relatively young compost. It's quite bacterial. I just like people being aware of where they can get these things from, and how they can use these tools um, and
Right.
definitely IMO2 limits that diversity. I mean, later on through the IMO process in KNF, they do mix the IMOs with composts or um, native soil or both. So they're probably in the end stages of IMO. They've got the protists, but yeah. If people are like making IMO2 and then putting it on their plants, thinking they're getting like diverse, higher levels of biology, I just wanted them to know that they're not.
Yeah, interesting. Huh. Yeah, actinobacteria, like a whole.
It seems to be. Is
This is
that
a good one.
slightly higher than who was doing these readings?
Perry,
It, it's the
my
same
friend.
guy every time, right? It's Perry.
Yeah,
Cool.
same guy testing different members compost around the country. Yeah.
Yeah. So is that the highest he's ever seen Actino
Good
on on,
question.
on
Good
the
question.
because in the EM
Does look pretty high.
consortia there's meant to be Actino, right? So you'd expect a little bit of lift maybe on the Actino. If you
Yeah.
made any notes about the types of bacteria he saw, like rod shapes or cocci, or if you'd imagine there'd be more rod shapes because I associate
Actino are
lactobacillus with
like the
EM.
strandy ones, aren't they? I mean, the most memorable bit about Actino for me was just like them explaining that wood chip thing. That's actinobacteria, isn't it? The white crust in a wood chip pile.
Yeah,
Is
yeah, for
uh,
sure.
but
But there are definitely actino in the EM consortia as well, right? And Frankia are actino. So we see actino in the beginning of a pile
yeah.
when oxygen can't diffuse into the pile fast enough that it's being used. So we see this like proliferation of actino in that environment. But later on, in like the later levels of succession, you see Frankia, which are an actino that fix atmospheric nitrogen.
Oh,
And they do it in reduced oxygen environments, right? So, and they can do it freely. They're free living nitrogen fixers. So they're just in the environment. They don't have to be associated with the plant to do it.
that's so
And
cool.
probably with fungi too. They most likely associate with lots of forms of fungi to get carbon.
Oh, that's so cool. So it's this getting this balance of air and water seems to be just like the most important thing, really. Can
Yeah,
you?
and if you look at the Olivia Hussarn redox potential graphs, what you're doing with EM is you're much more quickly acidifying the pile. And as when you do that, you're moving that pH parameter to a level that's more like a forest soil, right? Like biochemically, it's more like a forest soil than a young compost that you haven't done that with, I imagine, because the young compost you haven't used EM with is most likely going to be alkali. And when you're alkali and you're waterlogged on the redox charts, you're in oomycetes land. You're in
Yeah,
like
bad net pathogenic fungi or less good fungi.
yeah, in reducing, the ones that are in kind of waterlogged alkaline environments. So.
Yeah. So the girls, the Hay and Y girls are in danger of with that compost potentially. Yeah, because it had such high bacteria in it. Uh, and yeah, could bacterially dominated compost is super alkaline, right? Bacteria produce alkaline glues. Is that right?
Generally, yeah.
Yeah.
There's always going to be little exceptions to these like generalist rules, but yeah, most of the time they're
Yeah.
alkaline, they're yeah, more
So
waterlogged, stodgy.
yeah. So Bokashi making the compost more acidic. What would you recommend? So I've been doing a lot of work with these boxes. My friend Tim has developed this design, and they've installed 50 of them around Brighton now, and they are diverting a reasonable amount of local food waste and they're just putting them in parks and streets. They're great.
Mm.
They're rat proof, and they're made out of reused materials, and they're relatively cheap to make and reuse, etc. But what do you recommend? This is what we've been talking about recently on the forum is making adding bokashi to our post aerobically composted food waste. Would you recommend adding the bokashi to the food scraps, to the drawer, and to the bin here, adding more bokashi, even if you've got an EM spray or solution, make a little mix in a watering can just to sort of add more EM at this stage to sort of ferment it, because you can make these basically, with no gaps, or you can make them
I
with gaps.
think you're going to reduce pathogens and you're going to reduce the smells, and in urban environments where you really want composting to take off, I think it's probably a good idea. Yeah.
To add extra bokashi.
Yeah, I mean, I'm always up for people, who have questions like this to it's always good to do trials, right? Do it
Yeah,
with and
this
without,
is
see if
what
it's needed. See,
this is what
if you can pull it off and it's not smelly without it, then you might as well not use it. But
no, but I
if it
mean,
gets,
there have been examples of people are finding even after, depending on how they run their tumbler, like at full tilt, or if they're emptying it like every 2 or 3 weeks, and full tilt would be like emptying it every 2 or 3 weeks because you've got so much food waste, and then rats definitely come, and the problem is, you can't have rats in and
yeah,
get past the authorities in the city. So
sure, yeah, then
um,
yeah, I'd say then it's just a really good idea. And I think that kind of pH swing thing might be important for selecting against pathogens. Yeah, if you're trying to make good compost in the long
good
run.
safe
And
compost, yeah, in an
I
urban
think it might
environment.
have, on the DNA stuff we've been looking at, the bacterial young compost has fungicidal properties. So if you need to use a fungicide, if you're at the point where you've got some kind of pathogenic fungi in your crop, you could spray a bacterial compost extract, and you might be able to reap the benefits of that fungicidal
Nice.
agent or
And
those
am I right in
properties.
saying I often tell people, I often do like little things with the microscope, and people bring their composts in, and it's super hard to find any fungi for them because so many people have just made
Mm.
compost in Daleks, but it ends up being all brown and friable, and they think it's a nice compost, but
Yeah, it
it,
looks great to the gardener, right?
yeah, it still looks great. It's got the tilth that everyone loves and wants, but it hasn't got any of the life forms that we know are the valuable thing about compost. So yeah, how to what's the best thing they can do with that? I always say, look, all I can see in this compost is bacteria. Your best bet is to grow cabbages, like because that's what I've turned.
Yeah. I mean, that's good advice. Yeah, that's good advice. Maybe when we start using the DNA stuff, it gets a bit more advanced. We'll be able to tell people, we'll be able to potentially see uses for these different age composts, and then we'll be able to test them out, and trial them, and then tell people if they actually work or not. Like the bacterial compost having more fungicidal properties and the fungal compost having more bactericidal properties. Can we use those fungicidal or bactericidal properties instead of fungicides and bactericides in agriculture? Because if we can remove the fungicides and bactericides and all that, then we can
Yeah, man.
more easily establish biology to sequester carbon and build resilience and all that good stuff. But until we can remove those things, it's going to be hard to get stuff established.
Yeah, yeah. I mean, I just ultimately we've got to get God, we've got to stop the system of just like all the nutrients from the farmland going into the city and then just being wasted and lost from our fundamental food economy.
Yeah, well, it's good. Things are happening now. They really are. So, like we've got a few companies that have approached us and they want to change, and it seems like they're into it on a grand scale. So,
Wow.
um,
So
yeah. So there's not
have you guys
everyone's.
seen what the Catalyst Bioamendment guys are doing in the States? Do you know those guys?
Yeah, yeah.
They look they've been super inspired by them. I mean, they just got a field near a town, but they're just super careful with their inputs and they do it in windrows, and they do
Mm.
what you do in the clamps, the whole process. They just do it in
Yeah,
windrows.
well, that's what we're moving up to this year with
Oh,
kind of
cool,
that kind of scale.
great. I'd love to get them get arrange a chat with them because
Absolutely, yeah. They've been at it for a while, right?
yeah, I mean, and then again, not that long. I think it was 2019 they started. They just gone so full power because they
Oh
had just
wow, okay.
one of those things where everything just suddenly lines up and they've got loads of people, loads of energy, loads of and the land and everything just all the doors just open because it's such a good idea and the right time for it. So
Yeah, for sure, yeah. And out there, they've got the cannabis community as well, which kind of helps back them. Like there's lots of
yeah,
people looking for good compost from that. I mean, and wine growers too. Viticulture out there is massive.
that's so true. They're the markets for it, really, aren't they? Yeah.
Yeah, for
Um,
sure.
Amazing. Are you still selling some of your compost, Adam? And do you want to just say a few things about yeah, the Goop and what people could use the Goop for, any success, any stories about that?
Yeah, yeah,
Yeah.
cool. Yeah, we make this thing called the Goop. It's kind of a refined compost extract. Um, it gives it's I think it's cool because it gives someone a chance to see all these microbes. If they're doing the Elenium, of course, or if they're interested in microscopy. If they're not near like some old woodland with lots of cool microbes to look at, then they can order this thing to their door, and I think that's value in itself. It also helps fund us doing what we do, experiment to try and clean up agriculture, make a truly, biological, sustainable form of agriculture, um, using green waste sites around the country. So we're super grateful to people supporting us. If you don't want to buy the Goop, you can also buy the compost that makes the Goop. We've got lots of different composts, lots of different biomes to pick from, and fungal to bacterial biomass ratios. So you can get in touch with us and we can chat it out and find what's good for you.
Wicked, wicked. Oh man, thanks so much for your time, and that was really enlightening. We're going to do a load of trials with Bokashi in the secondary stage and like fermenting the Jora compost and the Raidan composts. And then Martin's also advocated we should start using the coffee grounds because there are so many coffee grounds that are such a valuable ingredient. And he says that making the coffee, like just adding Bokashi EM to coffee grounds, can just work instead of the bran.
Yeah, I
Um,
think that would make an incredible fertilizer as well for people's gardens,
mm,
especially
yeah.
if you have this like coffee compost, and then like
So would
you're
you? Yeah,
training up microbes to eat that, and then you've got this fermented like coffee fertilizer.
so
Sounds like that would be an
that could be
effective.
the long-term input. So you train the compost to you train the microbes in the compost to love that, and then
Yeah.
inoculate the soil with that, and then you can mulch and
Plus,
use.
it seems that that kind of coffee environment, again, going back to the Oliver Husan stuff with the redox potential, that coffee environment seems a bit less prone to oomycetes. It's just acidic, it's granular, it's quite aerated naturally. So it seems kind of better at growing these cool fungi that we're into when regenerating soils, like trichoderma, like penicillium,
Mm,
like these decomposer fungi that aren't water molds.
wow. Yeah,
So
yeah,
yeah,
yeah.
really, really cool potential with coffee. Another one to watch out for is cacao shell. this cacao shell byproduct. It's quite cheap. You can get it in bulk. It seems really nitrogen rich when we've tested it. So yeah,
Okay.
again,
Single.
like coffee, it's full of phenolics and antioxidants and cool compounds, and it's probably full of fungal foods, and it's pretty cool pH. I think it's probably similar to coffee because it's been fermented. So again, cool input.
Wow. Anything to watch out there? I know that the coffee, the cacao industry has got this awful fungicidal problem at the moment, hasn't it? Our friend Nicola Peel, who spoke with us a couple of months ago, she's been doing a load of trials with agroforestry and found really salute, but it's a chocolate blight. Oh no, fungal.
Yeah.
What's it called? Anyway, apparently it's chronic. Like so much
Mm.
chocolate can't get anything close to organic certification because of this fungal disease. They have to use so much fungicide on it.
Yeah, I mean, these are human created problems, I believe, with our
Monoculture.
systems and now they need um, they need natural ways of treating them. If we keep banging on the fungicides, we just make stronger pathogens.
Yeah, yeah,
I
totally.
used to be kind of phobic of this stuff in all these inputs. Now I've only been given more and more data to show me that where we put a poison out there, there's a microbe that works with it, right? So in the fields that we've done DNA analysis on, in every single sample, there is this microbe, Soleococcozyma terricola, right? It's a black yeast, and it cleaves glyphosate, right? And out in these fields where we're splashing on the glyphosate, there's these yeasts picking it apart.
Wow.
So, you know, yeah, there's lots of chemicals to watch out for, and we definitely should be conscious of that. But
But
where else
when it
are we
comes to
meant to
just
pick them apart?
composting, when we're hot composting the cacao shell, which may have been sprayed with the fungicide in the past, what
Yeah,
the compost process detoxifies, you know, organics, doesn't it?
it
It
can break down a lot of stuff.
breaks
Yeah,
down. Yeah. So
unless the
the
thing
best
is like
thing to do
completely
with it.
man-made, like DDT.
Yeah.
What's the other one? Aminopyrrolid is hard work.
PFFA.
These things require like light to break them down, right? They need to be in full sunlight, like with aminopyrrolid. So there's exceptions, but for the most part, yeah. I mean, and where we've seen plastic in piles, plastic tube in a pile, the DNA shows a plastic degrading microbe, right? A plastic degrading bacteria, where someone's got a tube, for heating their shower wrapped up through it. So,
Wow.
where you put these things, they'll microbes will show up to break them down. Mine had some microbe that worked with arsenic, right? And I put quite a bit of kelp in mine. Kelp
Wow.
can carry arsenic, so that could have been the reason I got that. So yeah, you think of these piles as you can apply selective pressures and you will get different outcomes based on those selective pressures. And if some of that selective pressure is a fungicide, a herbicide present, some kind of residue, you're likely to get um, microbes pop up that deal with that.
Wow. That's super interesting. That's super interesting. And one last thing, just a random one I've got to deal with. We had an event and we did compost loos and we used straw bales for all of the urinals. Um, the farmer couldn't give us any guarantee that they hadn't been soaked with glyphosate, and so they
Yeah,
probably were. Um, yeah, I mean I'm gonna hot
maybe
compost.
not last year because it was so hot, but
Oh, okay, yeah, when it was
if they
dry.
don't need to use it, they won't use it. But yeah, it's used a lot. So
Yeah,
yeah, if you're not getting it from an organic farmer,
problem, isn't it? And then you end up with this like these compost piles that you have to do, which are just like soup. You're not actually going to use them for any like necessarily. There's not. It's hard to sort of because you can't really human urine is problematic as well because people could have had antibiotics and
yeah,
best
that's
thing
a
to do is still compost it because that's going to like make it less of a problem. But
mhm.
it's not really gonna just ultimately just get plants and fungi to break it down in a non, cult. I still feel it's good to get this stuff to go back to the soil, so that carbon and nutrients can not get wasted. But yeah, I mean, it's just like it's more waste reduction and waste, harm minimization, isn't it, than composting to create living soil and health that we need.
Absolutely, yeah. There's always balance for your individual context. What you've got access to, what you're trying to make the product for.
Yeah,
Um, you got to ask yourself these questions. Not all compost is going to be the same.
no, no, absolutely. Wicked, man. Well, thanks so much. That was really interesting. I'm going to make a video if that's all right and share it with the group.
Yeah, no worries, anytime. Yeah.
Yeah, yeah. Wicked. All right. Any last thoughts or news or stories? Like, no worries if not.
No, just stay tuned to the lab project we got going on.
Yeah, yeah.
You can find me on Instagram at soil.ecology.agriculture or message me at adam@soilecologylab.co.uk. Feel
Wicked.
free to get in touch.
Any presentations or videos or anything like that you've done recently that is worth checking out?
I haven't done one for a while. Now we're getting on into the year. Um, we're starting to do trials, and we're just looking forward to more and more data to share with people. Um, yeah, and we do post some of those on the Soil Smiths website where you
Yeah.
can buy the goop. And
And
we
you've
do
also
post some
got
stuff on trials there.
Soil Ecology Lab, like mailing list where you do a Thursday session for
Yeah, so
everyone.
anyone who's done any of the courses, any Soil Food Web course, Eddie Bailey's course at Rhizophilia, or a course with us, or
Yeah.
it just involved and down for the hustle, making compost every day,
Yeah.
then they can get in touch with us and join the course and chat with us. We have people there like Ib from Denmark making extractors and talking about that. Trying to get high efficiency extractors for cheap. That's pretty cool. I like people just trialing our product like the Goop. We had someone trial it on radishes and got like 50% uplift
Wow.
in yield with just one application to seed. We've replicated that, got 20% uplift or just over 20% uplift with one application to seed. Now we got Charles Dowding replicating it. We got
Yes.
90% uplift in yields on carrots. Charles is replicating that too.
Wicked.
So hopefully
Wicked.
we're just trying to build more and more data in all these different areas of plant succession. All these, we're focused on wheat. We're also doing black currants. We're also trialing radishes and carrots. So we can build up more and more data on how this stuff positively impacts plants. And try and figure out how it's doing that.
Yeah.
um, and
And
share it
then
with you guys.
yeah, share it with us and then we'll spread it around and we'll start getting more and more farmers on board and connected and it's inspiring.
Yeah, and sooner or later, we're going to have this, not mass produced. It can't be talked about like that, but you
Yeah.
know, accessible product where a farmer can get a bottle or an IBC can land and they can mix it in with their water and they can go out and spray it. Because most farmers don't have time to figure this wacky composting out and
Yeah. They need
optimize it anyway and do it justice. Like use it to its fullest extent. Not every farmer has that time, so
time.
we're trying to be those guys. So yeah.
Amazing, amazing. And that reminded me there was a really important question that came up. So complete compost, the kind that like, we can make in all of these regions. So how much of it is needed to restore an acre of degraded farmland? Was it I had in my head it was a ton per acre of complete
Yeah,
compost.
so this is a question I guess that I get asked all the time, and I kind of refuse to give an answer to
Right,
it
right.
because
Oh,
it's such
so
a hard question to answer. Like,
yeah,
so we need a whole episode on this, but
yeah,
it depends how much microbiology you've got in it. How much are you getting off in the extraction process? Are you going for active microbiology? Are you an Inghamite? Are you a follower of Dr. Elaine Ingham? That's kind of where we're at. That's how we have molded our kind of approach through, and that we look for active microbiology stuff we can see on the scope and send out there, right? The Johnsonites, the followers of David Johnson, at the end of his process, there's not so much active microbiology, but there's a lot of seed inoculant, there's a lot of spores, there's a lot of microbial I mean, bacterial diversity, so it's kind of a different approach. And I'm always up for people like knowing which approach they're taking and calling an orange and an apple an apple. Um, so then when you get a failure, you made sure that you tested the system that you think failed, so you know where you're at with these things. But David Johnson has had mad success with 2 kilograms per acre. We use something more like 70 liters per hectare. Lots of people throw around 10 kilograms per hectare. So
That's nothing. That's
that's
nothing.
nothing. Yeah.
I
And
thought it
that's
was
coming from the
tons
angle
per
of seed.
acre.
That's a seed inoculum. That's not going to change the microscopy in a
Ah, that's a
single
seed
application, in a
inoculum.
double application.
Got
You're
it.
going to take years to get there like that. And you're
That's
going to need
crazy.
the other stuff in line, like cover cropping and all this good stuff, like um, adaptive grazing techniques and these things that are more kind of mimicking natural systems, biomimicry. If you stack all those things up, I think you can have good success, but don't expect the microscopy to change very fast. At scale, using amounts like that. I'm all up for pushing it as far as it will go.
Yeah.
That's why we made the Goop. That's why we want to try and concentrate
Yeah.
microbes to
We
ship
need to
them
get
out
those
there.
farmers spraying like the biology instead of the chemicals. That's ultimately the what has to happen, right? We've got to get
Has
the
to happen like that, yeah.
working for us and not just be suppressing it with these, really outdated, harmful systems.
For real, yeah.
Super, super supportive. Yeah, let us know and just post anything we can do to help you. Obviously, we're gonna spread the word about the Goop and yeah, all of also microscopy courses. I know that there's a bunch of people being like, I want to buy a microscope. Do let us
Mm.
know if you're doing any more of your one-on-one
We
microscopy.
do. We've done some this year. At the start of the year, we'll do some at the end of the year, and then we're not going to do some for the growing season because I think we're going to be too busy. But yeah, maybe autumn time,
Okay.
winter time this year, we'll be doing more microscopy courses. And if you've got a farm, you've got lots of people to teach. Maybe get in touch with us, and we've done events where we've gone to people's farms.
Mhm.
Um, so yeah,
Wicked.
you can get funding for some stuff as well. You can get a group of farmers in Scotland got funding to get us over and teach them microscopy from the council's government.
Adam, thanks so much, dude. I'm gonna love you and leave you, but yeah, it's been really great to talk to you, and yeah, look forward to more soon.
Well, good man. It's a pleasure. Have a good
Wicked.
night.
It's not bad.